Hello, everybody. Welcome to our next panel on blockchain scalability. It's my pleasure to be moderating this panel. So just to maybe set the scene, blockchain scalability is a topic that has become an increasingly large issue, specifically from an accessibility perspective, something that we saw specifically in the last cycle, and it's going to continue to be a major blocker in our journey to onboarding the next billion users into the ecosystem over the next decade. So it's my pleasure to introduce you to the four esteemed panelists that we have on stage with us today. Maybe starting with yourself, Sebastian, it'd be fantastic if each of you can introduce yourselves and the projects that you represent.
Thank you. I'm Sebastian Forestier. I'm the CEO of Masa Labs. So I have a background in computer science. I did a PhD in AI. And I've been doing research on consensus protocols since 2017 with my co-founders. And we started Masa Labs as a result in 2020. So what's Masa? Masa is the project of a scaled blockchain with no sacrifice on decentralization. We are now in testnet. We have 6,000 nodes, 2,000 transactions per second. And we expect mainnet in about 6 months.
Fantastic.
Sounds great. Hey, everyone. My name is Ko Kim. I head up ecosystems at Miston Labs. It's the team behind the new Layer 1 chain suite, which you've probably heard over some of the news. And so team was formerly part of Meta's crypto R&D team. So all the key individuals, such as the lead cryptographer lead, the R&D, the smart contract language inventor, so to name it. So. But yeah, I oversee all of our ecosystem growth initiatives and programs.
I'm Dennis. Hello, everybody. My name's not back there. That was a quick change of plans from last week. I'm part of Near Protocol, Near Inc. I'm a DevRel engineer there. For those who do not know Near Protocol, probably all of you do, but it's a level 1 blockchain, which has sharding implemented by design.
And speaking about Near Protocol, there is one solution on top of Near Protocol that is called Aurora. This is the EVM compatibility solution that allows everyone to launch their Solidity smart contracts or Ethereum smart contracts on top of Near. My name is Alex. I'm the CEO of Aurora Labs, the company that is building this solution.
Awesome. Thanks a lot, guys. So maybe just for the audience, the best place to start would be to set the scene for blockchain scalability. And I think let's start with the basics. So maybe you guys want to take a stab at why do blockchains need to scale, and what have been the biggest problems to scaling blockchains today?
So maybe I can start. Everything started back in 2008 when Satoshi was publishing his white paper. And the second comment on the white paper was, yeah, it sounds like a great idea, but it is not scalable. Right? Why it is not scalable? Because all of the servers need to implement or need to do the same operations, right? Which means that the throughput of the system is limited by a single computer. That was the core piece of the blockchain. And up until now, it stays the same for many blockchains. Ethereum is not scalable. Polygon is not scalable, right? Even Solana, though they are marketing themselves as scalable blockchain, they have the limit to which they are able to scale. It is higher than for Polygon and Ethereum, but still, this is a problem, right? And the scalability topic is super important, and that's why people need to work on this because of one simple number that I'm going to throw into you. So in Ethereum blockchain, there are 1.5 million transactions processed every day. If you will recalculate it, it is something like 15 to 20 transactions per second. This is super, super low in comparison with some of the existing Web2 protocols. For example, Visa, the card payment provider, is able to process 50,000 transactions per second at their peak load. So in case we would like to get to the point of the mass adoption of the blockchain, the point when cryptocurrencies are used as a means of payment, the point when we are immersed in the cryptocurrencies, I would say, well, we need to fix this thing. And for sure, the core of it lies in the protocols.
I'm going to add like a because I'm probably the most non-technical person on this panel, so I will translate on what the current state of blockchain is. And an analogy that come up, if you do have any technical questions, my teammate from developer relations engineer, Akasha, is actually at the front. So I like to kind of think of it as, imagine you live in a city or a little town, right, that just built out its first subway line, right? You know, like it's like literally one subway line. You're in a very small town. There's one line. Let's just call it 4 stops, right? So I get on and stop one, and I know I'm going to get off at the end of the line, right? So the subway line will just go on each stop, and because it's a small town, like there's not going to be that many people using it, and then eventually you'll get to your last stop in any means, right? Now imagine as this town grows a little bit, right? You can imagine that means more people are going to get on this stop, but there's still only one subway line. So, but is that subway line going to be able to scale? And so, like, so if you think about the city as it growing, more and more people got on the subway line. It's still just one car. It's still like, you know, and then eventually you're going to reach a point where you're going to have something called rush hour, and then all of a sudden you have all these people trying to get in on the stops, and it's going to take you that much longer to get to your stop because now you got to wait for everyone to get off the train and everyone to get on the train at each of these stops. That's the current blockchain world right now, right? So you're living in a world where there is no rush hour lines, there's no multiple subway lines, there's no way to like even organize everything. So that's probably a very simplistic view, but that's kind of like how I like to contextualize existing blockchain infrastructure right now, is that you're literally stuck with one subway line with 4 stops and unable to change any of it. So
This story makes me think about CryptoKitties in 2017.
right,
Yeah.
exactly, right? Like, yeah, like it's all of a sudden you have this network congestion, and you know what? It's like, I think that's becomes a problem, right? Because if you're a developer, like, you don't want to build on infrastructure where all of a sudden your API call is now going to cost you 500x more than normal, right? So that's kind of like how I like to explain things for people that are not that familiar with blockchain.
Fantastically helpful to set the scene. And it actually leads perfectly into our next question, which is, you know, let's actually talk about the state of scalability today in this present moment. And maybe it's actually interesting to have this conversation in the context of this point around over the last 18 to 24, potentially even longer months, you know, we've seen a lot of progress from a scalability perspective in the Ethereum ecosystem. So specifically, you know, we've seen workable layer 2s, we've seen a shift to proof of stake. You know, soon come, we're going to see potentially sharding as well. You know, is scalability not in that context a solved problem? Would love for you guys to maybe each respond to that, and maybe starting with yourself, Sebastian.
Yeah, I believe so. Layer 2s are doing an incredible job. Every month, they're showing new strengths, new limits to throughput, and it's really impressive. But it's still somehow slow because they have these problems with heavy computations at some point due to the zero-knowledge computations. But it's going to improve. So I believe in the next years we'll have something very workable without losing too much usability or security. Sharding in Ethereum, I don't know. Like I guess we're not going to see this in the coming years. In other projects, yes. So I believe there's still room for scaling other layer 1s.
Super helpful. Any of the others want to comment? Why take on this problem if it's, you know, seemingly solved?
Well, Near took it by design, so that's the nice thing about it. In fact, the dynamic sharding, that's what it's called. So on the network, you have your series of computers, and you want to distribute load based on demand on the available machines through the network dynamically, and that's going to be implemented, or it's planned to be implemented from the start of 2023. So, and right now there's been a lot of very big milestones have been achieved towards achieving that. And so, as I said, implemented by design. So I think, it's very important that CryptoKitties made me realize that you need to implement this from the get-go. Also, my experience in software is that once you have an entire software solution built out, that if you do it following a single path and you want to change that architecture to something completely different, that takes a vast amount of effort, and you might as well start with the right mentality. So.
For me, it feels that the overall blockchain technology is right now in the higher school, I would say. Blockchain developers are using very, very simple concepts like synchronous runtime, right? Which means that the transaction or your program is either executed or fully discarded, right? These approaches, in general, they are super simple and straightforward to understand. We literally teach them our children in schools. However, in order to get to the scalability point, if you want to design a system that works like Visa, it actually requires quite a lot of deep understanding and deep thoughts around how you can do it. We are starting to get there as the vertical. There are tons of things that need to be discovered, tons of things that need to be battle tested and put in production. This is not a simple thing to put some kind of new tech in production. You might be hearing within the previous year tons of hacks that are happening, especially with the bridges. That caused the loss of more than $2 billion within this year only. And all of this is happening because the technology is not on the level of that maturity. So we need to get there. There are great minds, there are great researchers, but still we need to make sure that technology is secure.
Well, I think another thing to keep in mind is when a lot of these smart contract platforms originally, when they originally came about, I mean, the main problem or the use case was they were designed to do payments between banks, right? Now you imagine, I mean, like, so all Ethereum, all that was kind of like, hey, how do we, do the settlement layer and become trustless between like two different banks? And the number of transactions that happen between banks is probably far less than like, even just like all the consumer applications in the world, right? I don't know if any of you've seen the kind of the graphic that shows what happens in an internet minute. The amount of data that passes through and the amount of interactions that occur is just another scale level, right? That I don't even think a lot of the kind of, when a lot of these smart contracts have originally been developed and the language has been developed, they just never took that into account, right? So I think it's like really interesting to kind of see what the current kind of new generation of L1s are looking at, because they're literally going back to the drawing board and seeing like, well, what is the data model that's needed for the Internet of Assets, right? Where the asset should have changing value, right? If you think about a payment, that number shouldn't change at all. Like I sure hope if I give you $10, that $10 should not turn into 12 or 5, unless you live in a country with 50% inflation rate, but like that number should not change, right? So I think it's really interesting when you're thinking about designing a blockchain for assets, especially if you think about games especially, right? Like those assets are going to change in value based on the environment they're in, with the history, all the values. And if you think about current blockchain right now, all of that metadata is not on chain. It's actually in a random database somewhere. So I think it's a really interesting world right now. So.
No, it's a really interesting point, right? The solution space, specifically in terms of use cases that are most relevant today, is completely different than it was a number of years ago. And I think a lot of the L1s that are building today are in the fortuitous position whereby they can think about those use cases and then build from first principles a layer one, a design mechanism, or use a design mechanism to basically build for those. So I think this is actually a really interesting moment to basically chat to each of you and get into a bit more detail about the specific design decisions that you guys have taken. Maybe, Ko, you want to just double down on what you were saying and speak to Sui specifically.
Yeah, so with Sui specifically, I mean, we just kind of came to the conclusion it was about the data model. And so we just believe most existing blockchain technologies were never really designed for assets. As I said, like changing value, different metadata states, different attributes, even just programmability, composability, all of that stuff that you need, even history, all of that stuff you need to model and be transparent on chain, just a lot of the stuff was impossible. So we kind of went back to the drawing board and be like, well, an asset in the end is an object, right? An object that could be composed of multiple objects to some extent. If you are in the Web 2 world, many programming languages are based on object-oriented programming languages. And so we kind of took that concept and brought it to the blockchain. So with this, and to some extent our chain, everything is treated like an NFT to some extent. But this NFT or this object, you can now basically compute and save different attributes. You can program logic against it. But then it also changes the way we do consensus. So if I'm going to go back to the subway analogy that I've talked about a long time ago, the way that since everything is now classified as an object, our workers can now figure out what the relationships that exist between objects, right? And based on those relationships, they can group all the relevant transactions based on the target object that hits it. So if I'm checking a balance on an account, like that's probably just a single writer object, right? It doesn't necessarily interact with any other object because the balance model as an object doesn't treat it as an object. Now, if I am transferring an object to another user, and that's like between two accounts, that's a shared object, right? There's different objects being used. So in the existing blockchain world, those two objects, or at least transactions, there's no difference. You have to order everything in the block, just like the subway. You have to wait till everyone's in line, and you have to wait until everyone gets off. In our world, we split it. So the single writer object actually doesn't even need to go through consensus. It goes because it's not interacting with any other object in the end, whereas the stuff that's in the shared object are also classified in groups. And that's how we reach our scale, is that we're able to parallelize the consensus agreements. So Siri got so excited.
I mean, I also got very excited,
Yeah.
and I think.
But the cool thing is about this is now we don't even have to wait till even the most complicated group of objects finish consensus. Let's say that just checking the account balance. Since that's going to skip, that can keep going to the consensus. That can hit the like verification and obviously the Merkle tree, right? But it doesn't have to wait for the most complicated group to kind of finish its verification, all that stuff. So that's the difference between SWI, and it's very different from a lot of existing blockchains. So
Super helpful. I mean, my one big takeaway for what you guys are doing is basically inserting accessibility as one of the kind of like key design principles for blockchain design, which is super interesting. I think something that I'd love to touch on later as well. Alex, maybe if I can point the conversation your way, you've obviously thought about accessibility a lot in the context of building an EVM. I'd love to kind of get your take on, the design principles that you followed, kind of sticking with kind of a very traditional set of design principles by building an EVM, but obviously innovating on that front as well.
Yeah, so in terms of accessibility, again, EVM is a super simple thing for the developers. For developers, it is a very, very straightforward way how to launch their applications. Just use EVM. There is a question which programming language to use there. There is Solidity, the most common one. There is Viper. There is this new language, Fe, that is developed at the moment. There are tons of things. But in terms of the accessibility on the user side, it is a little bit kind of perpendicular to the scalability of the blockchains. However, it is super important in terms of the scalability of the industry itself. We will never ever get to the point when we have mass adoption with scalable blockchain in case our user experience for using the blockchain is not good. Right. So this is a super important piece that I wanted to kind of drop in here. Not going to go too deep into this, but all of this complexity of the per transaction fees, gas prices, stuck transactions, nonsense, and need to repeat the transaction in case it is somewhere down there, or increase the price, or the concept of speeding up the transactions, right? All of these things, you would not be able to explain it to 1 billion under 18 mobile users who just want to play the freaking Fruit Ninja game, right? You cannot put blockchain like that in this game, right? So we really need to focus as an industry also on the user experience.
Got it. Dennis, any thoughts there from a developer perspective?
Yeah, I think as a developer, from the developer angle, which I have a lot of intersection with, is I noticed that there are a couple things they like a lot, and one of them is that the complexity is abstracted away from the developer. So handling networking, handling the sharding, availability of machines, when all these details are just abstracted away from the developer. This is one thing I like a lot, and they like a lot. Another thing is, in essence, Nier made the decision to use the WASM virtualization machine to run programs on the network. So that means that anybody can write their program in whichever language they choose, as long as they have the WASM file they can upload to the network that runs their program. And that's something also developers like a lot. So recently, in fact, we launched a JS SDK, which is right now in version 0.6, so still not a major release yet, but it's seen some massive adoption so far. And yeah, it's this simplicity behind before the complexity that I think yeah is a very important requirement in order for us to reach that 1 billion users.
Awesome. Maybe Sebastian, turning to you last, but not least, of course. I don't want to pin you to this, but decentralization is obviously one of the design criteria that you've really opted to focus on. Would love to kind of hear more about what you're building at Masa in that context.
Okay. So we started by looking at how Bitcoin and Ethereum work. So I'll go a bit technical, okay, but just a little.
Yeah.
How they work as peer-to-peer networks to share the data between the nodes. And we noticed one thing is that most of the time, nothing's happening. And then you have a node that creates a block at some point in the network, and the blocks get propagated to the full network in a few seconds, and then nothing's happening for like 10 minutes in Bitcoin. And why is that? It's due to the blockchain structure. Like we have a chain of block, a sequence of block. It means we cannot create the next block if we have not received the previous block. Otherwise, it would be a fork, right? So how do we scale up in this context? You could say, like, naive idea would be, okay, we create bigger blocks of, I don't know, 20 megabytes. Bitcoin Cash did that. So to some extent, we can do that. But you cannot do gigabyte blocks because they won't have the time to propagate in the full network because we suppose that the network is pretty well decentralized. Okay. You could also have smaller blocks more frequently. Ethereum did that, so we can do that to some extent. But you cannot do smaller blocks like every second because the block will not have the time to propagate to the network. So in the end, you see the only possibility is to create blocks in parallel if you want to have more data going through the network at the same time and not to wait for the previous block to be able to create a new block. That's what we did at Masa. Nodes create blocks in parallel threads, and a node is allowed to create a new block even if it has not received the other blocks of the other threads. This is what making the overall thing faster. So of course we had to adapt the Nakamoto consensus. So you know the rule that says in this tree of blocks, what is the best chain of blocks? It's the chain with the most work. We adapted this to a graph, a multi-threaded graph of blocks. And with this architecture together, we can reach 2,000 right now in the testnet transactions per second in a truly decentralized network where each node meaningfully participates in the consensus. And that's the difference with most other approaches, where you will see that, in fact, maybe 10 nodes, 20 nodes max are meaningfully participating in the consensus.
Got it. Super helpful, guys. Maybe kind of, there's room for debate here, right? Because we've discussed a variety of different kind of blockchain design criteria. Obviously kind of the three main include scalability, security, and decentralization. I know accessibility is, I think, something that is becoming, increasingly relevant as well. I'd love maybe just for there to be discussion on, is there one that matters most? And maybe as a follow-up question to that, are there any approaches to scaling, or are there any approaches to blockchain design more generally that allow you to meet all and not just 2 to 3?
So I'm going to take my perspective on an L1 or anything is it's in the end it's a platform, right? And platforms are defined by the builders that are creating content and tools on top of it. Like you can have a platform, but if no one's building on it or if there's no users, then even if you have the best technology, right? Like no one's going to care, right? So this is like where I think accessibility matters a lot, right? Because time is like your most valuable asset, especially to a developer who's trying to get themselves like onboarded up to speed and all that stuff. So I think for any L1, the most critical thing is really thinking about like how do you shorten that time for a developer to launch their application onto that platform, and not only that, how do you help them so that they can scale? And so, and that's why I think accessibility matters a lot, because if you compare a lot of the tooling that's in the Web3 world compared to the Web2 world, it's actually kind of annoying. I mean, the words that are used by my developer friends are pretty funny. They're like annoying, frustrating, why am I doing this? Like, it's kind of like that. And so, because convenience is a very strong human emotion, right? Like, you can get stuff built easily, right? In like the old Web 2 world, where it's actually really, really, I would say time consuming, very like, I don't know, almost aggravating, because a lot of the things you have to think about, because as I said, like existing blockchain models, I've always thought they don't think about things in an object sense. Everything has kind of been built for like address-based ledgers. And so to some extent, it's not really intuitive to what they're used to, right? And so, and I think that's for us, that's why we've kind of taken more of this object-oriented approach, because that's like a more natural kind of progression for a lot of people coming from the Web 2 world. And so I think there's a lot to be said about like, how do you get developers to market faster, right? Instead of trying to basically reinvent a wheel and many other things that probably are not used reinventing, right, if they exist. So,
does anybody else want to jump in with the final answer? Because then I think we have to jump to Q&A. Understand it's a meaty question, but 30 to 60 seconds would be awesome.
Well, to me, saying that only one thing is important when taking all these things into consideration would be too simplistic of an answer. We would like to, at least how I've seen things play out, is that you want to make things as easy as possible for end users. You want to make the learning curve as comfortable as possible for developers, and at the same time, make sure they're conscious of what they're doing and aware. And on the other hand, you want to build the most robust code for your network that you can. So you have to take these things into consideration and make decisions in each. And I think giving one answer that, yeah, we go full on scalability, it's going to be a trade-off. So you're going to sacrifice a bunch of different things for that one thing. So
awesome. Yeah. Thanks a lot, guys.
I think we have time for 2 questions. Let's get this one here in the front. And just give me a raise of hand if there's anyone else that has one, so we just know where to track you. No? Perfect.
Hi, this is Michael. So, question with 2 stages. So the first question is, I understood about the scaling, but as a developer of such technology, what would be your recommendation? How do we choose? I think we have 3 choices now on the stage. So what would be my criteria to choose the technology that would enable me to scale best? And the follow-up question is, do we expect or should we expect consolidation of standards or anything that resembles standards, that things can be interoperable with each other? I came from a bit of a background of networking, so the only thing that enabled networking was the standardizations. Without that, we would be still talking in different languages. But what happens with the Web3 scaling challenge, considering that evolution?
I can take you. Michael, thanks for the question. In general, in terms of scalability, the best answer would be for you just to go do a simple proof of concepts on all of these things and check out the load testing, because in most cases in blockchains people are talking in marketing terms. Let me put it that way. So so just go and try it. It most probably with any of the blockchains. Just to load test the blockchain, it would take, well, at maximum 1 day of the developer in order to check it out. So this is first answer. And second thing, yes, indeed, there is a big problem of the standardization. The problem is mostly the inconvenience for the developers, because they can develop something for one blockchain, but something is not working there. It is very hard to migrate. So you kind of have this vendor lock-in. And de facto, what we see in the market right now, that EVM itself, this virtual machine that was developed for the Ethereum blockchain, is becoming a standard. So in case you're writing your code in Solidity, well, there are many different blockchains where you are able to apply it. In case you're writing your code in some kind of different language, it will be a little bit or much more complicated. So if you are to start your blockchain business right now, I would recommend you to choose Solidity as a programming language, though it has tons of problems. However, it is much simpler to find experienced people also.
Alrighty, thank you very much, guys. Can we have a round of applause for our panelists here on the scaling panel?